Symmetry elements and operations consist of 5 different things, which are identity E, axis of rotation Cn, plane of symmetry sigma, improper rotation Sn, and lastly center of symmetry I. Thus, from all these 5 things, you can determine the compound's point group. Alright, so first of all, every molecule including sulfur hexafluoride has C1. Since it can rotate through 0 degree and leave the configuration unchanged, C1 is also known as the identity of the compound, notated by E. The next one, SF6, has 3C4. The molecule can be rotated by 360 degrees over 4, which equal to 90 degrees about the axis, and still leave the configuration unchanged. This is the first C4. The second one, the third one, since it passes through the S atom at X, Y, and Z axis, rotations can be 3C4 power of 1, 3C4 power of 2, and 3C4 power of 3. Also, this is the highest possible number of n we can get. So, C4 is the main axis of the molecule. Now, let's move on to the C3. C3 exists when the molecule rotates at 120 degrees about the axis. In this sulfur hexafluoride molecule, we have 4 C3. From this view, one C3 is passing through the sulfur atom from the middle, and then the other 3 can also be observed from different views. So this is the 2 C3, 3 C3, and 4 C3. Rotation can be C3 power of 1 and C3 power of negative 1, or also called as C3 power of 2. In total, you have 4 C3 power of 1 and 4 C3 power of 2. Moving forward to C2, in which the molecule rotates at 180 degrees, this molecule has 6 C2 passing through the fluorine atoms, and in between the fluorine atoms, 1, 2, 3, 4, 5, and 6. In this part, we are going to identify the plane of symmetry notated by sigma. The first one is the sigma h. Sigma h is perpendicular to the C4 main axis. Since we have 3 C4, thus we also have 3 sigma h. Next is sigma d. Sigma d bisecting the angle between the C2 perpendicular to it. For example, this is our C2 and this is also our C2. Sigma d exists in between these two C2. Thus, we have 6 sigma d corresponding to 6 C2. Last but not least, the molecule also has few improper rotations, known as Sn. A molecule is considered to have improper rotation when it can rotate at n axis, then reflect in a plane perpendicular to the Cn, but still distinguishable from the original. For SF6, the molecule rotates at 90 degrees and 60 degrees, then reflecting it in a plane perpendicular to the respective axis. Therefore, improper rotation can be 3s4 and 4s6. For your information, sulfur hexafluoride has S2 that is also the center of symmetry, I. These are all symmetry elements and operations that exist in sulfur hexafluoride. Therefore, its point group is octahedral OH. That's all from me. Thank you for watching.